Hello and welcome back to the course on blockchain. And today we're going to talk about smart contracts. Alright, so what is a smart contract? What is it used for and how does it relate to blockchain? Well, despite the name, smart contracts are actually programs which are run on the blockchain. I know it might be a bit surprising that it's called a smart contract while it's actually a program. Well, when you think about it, what is a contract? A contract is a set of rules that, or a set of clauses that parties agree on that govern the relationship between them. So it basically says that if this happens, then this should happen. If the parties decide this, then this should happen. After this should happen, and so on. And essentially, if you think about it, then programs are the language programs speak the same language. So in programming, you also define rules, how a program operates. If this, then that. If that, then this, and so on. And so it's not a surprise that smart contracts are actually code that can go on the blockchain. Now, we haven't spoken about code on the blockchain before. We've talked about many things. We've talked about data on the blockchain. We've talked about transactions on the blockchain and things like that. But code on the blockchain sounds very, very interesting and kind of very sci-fi-like even. How can you run code on the blockchain? So let's talk about that a little bit more. We'll start with Bitcoin. In Bitcoin, there's a programming language called Bitcoin Script. And it actually allows you to code things on the blockchain. At the same time, in Ethereum, there's a programming language called Solidity. And it allows you to code things for Ethereum. And for this tutorial, for this section in general, the difference between the two will be a very important component of our discussions. Or it's like lays the direction of our discussions. Why are we going to be talking mostly about Solidity and Ethereum? Well, the reason for that is Turing completeness of a language. The thing is that Bitcoin Script is not Turing complete and Solidity is Turing complete. So now you might be asking, what is Turing completeness? What does that mean? Well, Turing completeness means that if a program language is Turing complete, that means you can code absolutely any logic into that language. So anything you can think of, any logic you can think of, or write on a paper, or have in your mind, you can code it into that language. How long it will take for that code to run is a different question. It might take a few minutes, it might take a few days, it might take a few years, but that doesn't matter. It's about this conceptual notion that you actually can code it in. It has all of the required elements to facilitate that logic. Well, why is Bitcoin Script not Turing complete and Solidity is Turing complete? Well, because in Bitcoin Script there is one component that is missing, a very important component, and that component is called loops. So loops, if you're familiar with programming languages, you know what loops are. You know, the for loop or the while loop, that type of thing. But if you're not familiar with programming languages, it's basically a loop is a way for you to tell the program to do a certain piece of code many times for many iterations. It's either you might say do this 500 times or do this 1,000 times, or you might say keep doing this until a certain condition has been met and certain state has changed, and then stop or break the loop. And the reason it's not in Bitcoin Script is not by accident, it's intentional. They did include Bitcoin Script because, as we will see further down, smart contracts or programs on blockchains, they actually run on every single node in the chain, and they can really slow the chain down. So if somebody intentionally or non-intentionally creates a program that has, for instance, an infinite loop, a loop that doesn't have an end, it can destroy the whole blockchain, or it can hang the whole blockchain, or slow everything down significantly, or even not an infinite loop, just a big loop. Somebody might do like a very long loop, a very tedious loop. And so loops in general in programming generally are a dangerous tool if they're in the wrong hands or if they're used incorrectly. And so to avoid any kind of problems, potential problems with programs like running forever or going into infinite loops, Bitcoin Script decided not to include loops. Solidity, on the other hand, found a way to include loops, and we'll see how further down in this part of the course. And interesting note here is that I think I read somewhere, watched somewhere that, anyway, I heard somewhere that Vitalik Buterin was actually advocating for Bitcoin Script back in the day before Ethereum. He was advocating for Bitcoin Script to include loops and make it Turing complete. because there's so much potential for so many things you can actually create by coding on the blockchain. At the same time, they didn't see much of an uptake on that, and so you went ahead and just created Ethereum and Solidity. How interesting is that? That's one of the reasons why we now have Ethereum and Solidity. And okay, so let's have a look at this on a blockchain. So there's a blockchain. Now a new block gets added to the chain, and in addition to adding transactional data and other data, we're adding a smart contract. And so what does that mean? That means that everybody in our network will actually have a copy of this smart contract. So that's pretty crazy, right? So like one thing is to have some data copied onto your machine. Another whole thing is to have a computer program or a smart contract or program copied to your machine, which will run there. And everybody has a copy of it. That's like it's an unfathomable concept. And yet it is what happens. And so each node has has the history of all smart contracts. So if there were any previous smart contracts, they will be present on every node. Just because of the nature of the blockchain, you get a copy of the blockchain. The whole blockchain gets copied to every machine. So that means all the smart contracts will be on every machine. There'll be a history of all transactions, as we know. So if there were any transactions before, and there were tons, and they will also be on every node. And also every node has to have the current state of all smart contracts. What does that mean? That means, well, the smart contracts, they're programs, and they execute and so once they execute, they get into a new state, and then they execute, something happens, they get into a new state. So every node will know in which state this smart contract is, this smart contract is, this smart contract is. So there we go. That's smart contracts in a nutshell. I know it's like a lot to take in right away, and so that's why we're going to leave it here for now. We'll continue further down. And at this point, what I wanted to share with you is an example. So here we've got provenance.org /white paper. This is a white paper which just discusses explains how they're planning on using blockchain in supply chains to add transparency to supply chains. And the reason for this, the premise for this is that often we buy products and we don't know where they come from. Like you might be buying coffee that you think is from Ethiopia, but it actually comes from somewhere else, maybe just like on a farm somewhere in your local country or somewhere where it's cheaper to grow it, but it's more reputable to say it's from Ethiopia. So how can you tell it's from Ethiopia? There might be a sticker, but is that sticker valid? Is that sticker a true sticker? Anybody can stick a sticker onto a packet of coffee, and that's not only to do with coffee. That has to do with pretty much any product that you purchase. Is this meat from a free range farm, or is it not from a free range farm? Is this, I don't know, is this are these clothes from a proper production factory, or are these clothes from a factory where they use like a, what is it called, like a sweat factory where people are underpaid and they are not treated well and they have to work lots of hours and so on. So with that, the idea is pretty solid to create create transparency in supply chains, and blockchain, as we know, is a great way to do that, is the prime candidate for that because of its distributed nature, because it's tamper proof, because it's so it has all those amazing properties. And so how would they do that? They explain, well, basically the same thing that we just discussed, the premise for it. And here they have a little diagram which talks about what it is. So we're talking about certificates, how the certificates are issued right now. Certifier, this is what happens today. So there's a certificate, and then consumers don't have full visibility, don't have access to it. What they want to create is, as we can see, this is our network, and all of these certificates actually sit on the blockchain. Well, to facilitate that, they would use smart contracts. A smart contract would say, okay, so when the product is sourced in Ethiopia, let's say the coffee, and it's scanned with this bar scanner, if that happens, then put this checkbox, check this checkbox. Then once it gets on the train, check this checkbox. Once it gets on the ship, check this checkbox. And every time it's scanned, because we have like the Internet of Things around us, there's so many scanners, there's so many checkpoints that actually can be digitized. It's very easy for these things to be confirmed that like it was physically scanned in this location. And the smart contract would have logic coded into it, which would say, if this then that, if this then that, and it's non-disputable. It's hard coded logic. Nobody can come in and tamper with it. It's a smart contract that's been uploaded now we can see better why they're called smart contracts, because at the end of the day, it's like people or companies are interacting with it as a contract, and it's treating this relationship as a contract. So once certain conditions have been met, certain things happen, and at the end of the day, the certificate is issued, and you can go online and you can have a look, on your phone, take a photo. They had a good one here somewhere. There, like take a photo and see all of the details of what this product went through, what was happening along the way, and get all the information, and then you can be satisfied or dissatisfied and purchase or not purchase said product. So there we go. That's an example of using smart contracts to disrupt a whole industry, and which is supply chains, and create a lot of things there. So that's Provenance. Then I also wanted to show you, if you go to Medium and you search for smart contract, you will get a lot of results. So, and look at the number of claps. It means people are reading them. So you got build your first smart contract, Ivy for Bitcoin smart contract language that compiles to Bitcoin. Oh, interesting. So you see there's something for Bitcoin script. Smart contracts for dummies. Build your first Ethereum smart contract with Solidity. They're mostly for developers, and because people are actually coding on the blockchain. It is the future. It's the next big thing, and a lot of people are writing about this and helping each other out how to learn it. So it's quite a popular topic. It's really catching on, and a lot of these are very recent, like end of 2017. I'm not sure. You might be watching this video like a few years later, so they might not be recent anymore. But nevertheless, smart contracts are picking up. And to finish off our additional reading for today, I really like this article, Smart Contract for Dummies. I enjoyed reading it. I learned a few new things from it, and it's got almost 2,000 claps. Highly recommend it. We'll link it in the course description, course notes. It's really funny. I like how he describes smart contracts as stones, like as in, let's set this in stone. I love this phrase. He had the phrase here. Like, there's a reason we don't say, let's set this in sand. It was so funny. And then he has that example of a vending machine and so on. So highly recommend. Very short article, but it will give you an additional perspective on smart contracts and show you how they work from a different angle as well. All kind of like from a just same thing, different explanation. All right, so on that note, hope you enjoyed today's tutorial. Look forward to seeing you next time, and until then, enjoy blockchains.